Bismillahirrahmanirrahim. Is architect Muhammad Amir Saleem in class Architecture Structure 2, Semester 4. So today our topic for the discussion is this lecture is the high-rise building. So it is the continuity of the last lecture. So we have to discuss our objectives today. It's the key point of our last lecture. This The last lecture is 100% relate this topic today with the high-rise building. And secondly, we will go for the new topic is the tall buildings are high-rise structures and the new government policies. And in this lecture, we will discuss the structural design, its issues and analysis, and determine the most and important factor for the architects to understand is that basically the understanding of the hierarchy structure during the design. And furthermore, we will discuss the new technologies and methodologies for the hierarchy. So we will start our lecture with the some key points of the previous lecture, and the new lecture is also based on this aspect. So what is the importance of the lateral stability in a structure for the architect? As we have done an assignment about the fall of Margla Hills Tower in Islamabad in earthquake, the basic cause of the fall of that building was the weak design and the weak stability in respect of lateral movement. So the lateral movement, the definition is the lateral movement is basically directly related to the dynamic loads. The to and fro movement is cause the damages and create a problem for the structure. If the structure is stability is really based on the very interesting point of the lateral stability, the structure will remain stable. The secondly, the objective is when we go for the high-rise building, the dynamic loads. Dynamic load, we already understand the wind pressure, your wind load, and the earthquake load. The basic two aspects of the dynamic load will affect on the building if the building is not clearly designed with respect to lateral stability. So it is very difficult to control and save the building. In the previous lecture, we have discussed some the methodologies. Number one, the shear walls. So this is one of the easiest way, and we discuss in detail what are the shear walls. And then we have a brace walls style of save the lateral movement for lateral stability. We have a brace styles. We have a diagonals. We have a K shapes. We have a knees. So we have a different styles to make the building in a very stable condition and safe from the lateral movement. Nowadays, we know in the last lecture and we discussed the Lahore and Islamabad are in a zone 2 area with respect to the earthquake. So in our capital cities, Islamabad and Lahore, we are going to design the every building on the Richter scale of 7 that is given by the government. The NESPAC has clearly mentioned that every building should be designed with the safety of a Richter scale of 7. And the earthquake is directly related to dynamic load. And when we are going to discuss the dynamic load, so it's very clear. So we have to save the building from the lateral movements and moreover for the lateral stability. So in the high-rise buildings, So now we're going towards our new topics. So high-rise buildings, as we know and we discussed, are majorly affected by the lateral movement. So when we are going to move toward the tall buildings, so we are discuss very shortly the new government policies. The new government policies with respect to tall buildings and high-rise buildings. The government is decided in capital city Lahore as a new vision of Lahore. The government supposed that we need a high-rise buildings to accommodate our people in a residences, and they are going to make a high-rise, or we easily in a simple and architectural language, we are going a vertical housing schemes. And government has really changed the different uh, policies and make a suitable policies, make a favorable policies for the contractors, for the architects, and for the developers. The government encourage and support the tall buildings. So when we are talking in the capital city like Lahore and Islamabad and Faisalabad and Karachi, the government really encourage the people to make the high-rise buildings. So my dear students, we as a student, as an architecture student, we must need to analysis and have a clear concept during the design of a high-rise. So with the support of the government, policies, and the new visions, and the most important is the demand of the current age. In urban cities, the distances increases, the workplaces is away from your houses and residences, so you need a vertical building. So my young architects nowadays in capital city Lahore, you saw the number of residential vertical buildings. That's what we said in our architectural language, vertical housings. And they all are sold and provided a proper facilities, infrastructures. So in this lecture, we will discuss some suitable solutions. And these solutions are not a particular architectural solution. These are the solutions as for architects just must consider before the designing of the tall or high rise. So as we discussed, the tall buildings are particularly susceptible to effects of lateral forces. And the lateral forces are the lateral loads, the same word, a same consideration. So the effect of the lateral forces is really faced by the tall buildings. And most important, the rigid frames in the least efficient way to achieve the lateral stability and is appropriate only to the low to the medium rise buildings. Dear students, you saw the different buildings around your vicinity and you saw in the Lahore. So all buildings are the column frame buildings. And in our previous lectures and before the midterm, we have discussed the column frame structures in a concrete, in a steel. We use a word. Clearly, now you understand in this lecture, the words are rigid frame structures. So you saw the buildings around your vicinity, they all are the rigid frame structures. They are considering as a low or a medium high rise buildings. So efficiently, these buildings are easily managed with the size of the columns, with the increase the size of the column, increase the size of the beam, it's a cross-section area, and we create a rigid frame and we are converted the building into suitable and lateral stable positions. But when we go the high rise, the tall buildings, then we are facing some other problems. So when we increase the height, it is necessary we have to add some other mechanics in the structure to form it is a stable and very stable and safe for the residents. So we use some mechanics like a diagonal brace. The word is bracing we use in our lateral stabilities in lectures. So diagonal braces are the rigid cores. So rigid cores means in other are fixed and permanent and having a very effective connections core. This is called the rigid core. So an efficient type of high-rise building structure is a tube structure. So we come in the solutions that we think that the tube is the best solutions. It's safe from the lateral forces and it resists and all other columns and beams are directly linked with that tube that face the structural forces and all are internally attached with a brace system. So this is the basic result, a formula that we derive now in this lecture. So when we are going to a very much and increase the height of the building, we are going to use the tube system, and tube is attached with the rigid frame structure through the braces. And other more we will discuss elements for the tube and the other high-rise structures. So as we discussed earlier, so in Pakistan, in Lahore, you have seen these all buildings are executed, they are a medium scale and high-rise, all are incorporated in a rigid frame. So here we are not much required the tube and other structural mechanics. Simply, we make it a rigid frame, as I discussed. So we increase the size of the columns, we increase the raft, we increase the foundations, and in a lot of other aspects. So we change and make the rigid frame with the structural gaps. So these are two buildings which are shown in the slide. Basically, is a rigid frame structure. And now we come back to the solution of high-rise buildings. An example of high-rise building is a structure in a tube structure. So though we are going to decide the tube is basically a structure in which we are going to make a suitable high-rise buildings. So now, and we are discussed the basic concepts of the tube. In this slide, the picture, the diagram reflects we make a rigid tube in the building. When an architect is going to design it, so make a tube, make a shear core, make a connection of a tube, and all other columns and beams are rigidly connected with the tube. And this is the all forces are going to be concentrated at the center point. So in the simple word, we make a tower, a column, a rigid frame, a tube in the center or anywhere else. So we as an architect would design. So all columns and beams are rigidly attached with it. So this is the basic fundamental composition to design a very high-rise building. So on the other hand, we are different other aspects and compositions, but the basic frame and methodology is basically a tube structure. Another now we discuss the perforated shell tube has a perimeter shear walls with less than 30% of surface area perforated by the opening. So it's very clear, students, we are going back to the last lecture, the shear walls. Shear walls basically help and support the main columns, the rigid frame structures at their ends to provide to save the building by the shear moments. And the shear moments are developed by the lateral moments, and lateral moments developed by the dynamic loads. And dynamic loads are developed by the earthquake or by the wind pressure. Now, this is one factor. Now we understand the shear walls. Now we come to the second aspect. So we have perforated walls. What is the objective? So we are going to design the shear wall perforated. It means that we are going to reduce the weight of the wall. I use the word weight. Weight and shear wall is basically a dead load wall, a dead load. And dead load is directly related to the static load. So again, when we are going to perforated walls, perforated shells for the tube, it means we are going to reduce the overall weight of dead load, static load of the structure. Number one. Number two, we provide the shear walls. That means that it reflects to support the main core for to save from the lateral movement, and the most important for the architects, it may be increase the aesthetic of the building. It look nice, it look beautiful. In the holes and perforated areas, we use a glass or any other decorative elements. So we use the tube, and we use the tube on in a rigid frame as we discussed, but to reduce the weight, to reduce the most important is the cost. So another important factor I just want to add from the project management. So we need and we want a large scale production. When we are doing the large scale production, we really also want the quality. When we need the quality and the quantity, the consumer always request and they desire the low cost product. So this is the basically the system, the project management. We achieve the best quality, best stability in the structure, best design in the structure, but it should also be at a lower cost. So this tube structure, perforated shell structure, may also be fulfilled, not 100%, but very close to our requirements. So this is another style which we are using in our high-rise building. And the other system is, this is very commonly used from a making of the table to the high-rise building. The brace tube is a framed structure tied together by the system of a diagonal braces. So it's very clear. So when we are making a high-rise water tank, overhead water tank in a society, you saw they make the columns and they brace them with a diagonally braced tie beams, and they make a overhead tank. In this structure, so we make a tube, and all other columns and beams are tied up with the brace diagonal beams or any structural materials. We make this structure in a steel, we make a structure in a concrete. This is a two-way only. So we make a high-rise. So and other important aspect which we have discussed now, the brace system. But the all brace system, diagonally brace system, as shown in the picture, it goes together or tie up with the rigidly framed structure. And this is a considerable, it's considerable a safe and sound structure. And when we are making this structure in a concrete RCC, reinforced cement concrete, so it is considering a easy to execute and is easy to handle. This is a generally mostly considered in the best practice in the concrete RCC structure. So this is another example of the high-rise building design. So another important, in the last few lectures back, we have discussed the truss system. When we are going to discuss the spanning system of different building materials, so we discuss the truss system. It's a very common, we use the truss in our building when we are design our truss system in a building. What is the main objective? Very simple, and we discuss it very clearly. So our truss maybe in a beam, maybe in a wood material, or maybe in a steel material, or maybe in any other material. The main objective of the designer, of an architect, is long spanning system building. They make, in this system, in the truss system, we make a widespread column types together by diagonal cross spacing. In ordinary system, when we are making a shed, factory sheds, or maybe a high-rise, any uh, shed or any factory areas, we are using the truss, steel trusses, and make it very long spans. So basically, when we use the word and we are considering and we are going to design a truss system, that means we required a wide spread columns or a long spanning building system. So if in a high-rise building, we required a lesser columns in a wide spanning system, so we use the truss tube system. They are again diagonally cross braces attached with the main core of the tube, and they are really a face, and the lateral movements are in a stable position. So the truss tubes be trussed walls frames of widely spaced columns tied together by the diagonal or the cross brace. So in a high-rise and a long span system, we use this method of the truss tube system. And another system, this is basically again the lattice truss tube has the parameters frames of closely diagonal with no vertical columns. The lattice mean, this is, we have discussed already, this is triangle type of trusses that's required. Definitely we have an end two supports, and we use a long spanning system. This is another type. This is second type. That's the, in the last slide we discussed the truss system and lattice truss system, in which the trusses are in triangle shape. So they use also for a much more longer spans system in the building. And other students, here's a very interesting, and nowadays this system is very popular in the market. As an architect, as an engineer, they use this system. So that's called a bundled tube system. The bundle tube system is an assembling of a narrow tube tied together to each other to form a modular structure that behave a multicellular box. So we use a different tubes, and they are tied up with a different methods and make a multicellular box. So it's provide and is safe. The lower portion of the tall structures where the lateral forces resist is needed. So definitely the lateral forces that develop from the lower portion of the building when an earthquake is on and they have moved the plates in the to and fro motions. The major chunk and important factors, the effect of the building in the lower portion. And when we have number of tubes are over tie up with together, so it make a really a good stability in that area. So in skyscrapers, the bundle tube structure system are really nowadays very common. They are used in the materials, as I discussed, in a steel structure, and they make a cluster of the different tubes. This system basically minimize the important steel need for the high-rise tower and eliminate internal wind braces. So it's a very important. So in the next slide, you have to clear understanding. This is the clear understanding. On the right side, all buildings are tubes are there. So here are five tubes at the lower portion. At the bottom, we have five tubes. They are interconnected with each other. So it will resist to the lateral movement very positive and affect the building of the lateral movement is very minimal. So all the basic formula, the formulation is to make a tube and fix with the rigid frame structure. One, this is two. And now we make a 4 to 5 or 6 tube structures, tie up with each other and make a rigid frame around it with a different scale of heights. In this way, the bottom, the foundation area is really effective to resist the building lateral movement. So here is a very precisely we discussed the important factors during the designs. All tubes are properly proportionate and properly geometrical designed. They are interlinked with each other. And the most important, my young architects, it's very important. It fulfills the all requirements, all demands of the structure that we are going to design. If we are going to vertical building for the residence, the vertical housings, it fulfills the all requirements like orientations, like a wind, like a view, like comfortable inside the building. So an architect, we must design these buildings very carefully and design the cores, main core or a tube in a very suitable way. So this slide really clear the basically bundle tube system in the higher structure. So this is another the bundle tube structural system. So this is reflect the different buildings are designed in the world, in Malaysia and other areas of the world, designs in the different aspects. So in Lahore, we have seen the main boulevards. We saw a building that's not a tube structure; it's a rigid frame structure, but they are basically when they are at the lower portion, they design to 4 to 5 story for the commercial, and they reduce the building when they are moving upward. So they are 15-story buildings, but they are not close to. They are basically copy of this, but this is not that is not the bundle tube structural system. When we move ahead, so this is the most interesting, and this is I think is a really very uh, safe way to design for an architect a tube in a tube structure. This is really very interesting. So when we are going to design a tube and in a tube, and they are the both tubes are tie up with a brace beams, a bracing system, and this system improve its shear stiffness and resisting the lateral forces. The all movement goes to the building to save from the lateral forces. This is the basically a very suitable process. So when we make a tube in a tube, so I will discuss the assignments in the later after this slide. So we as an architect design a tube, and we in it again are a outer parameter we design a tube. So they are connected with each other, and this is of a beautiful way to achieve the longer span, to achieve a better play in the building. And you also say these buildings are very popular nowadays. And the most important is it very easy to execute. Just have to make the two cores. If you are making in a concrete, if you are making in a to tie up with the each other by the bracing system. So tube in the tube structure is also followed by the geometrical. As an architect, we always request to all my students, they must understand the mathematics, and the mathematics, the subject is the geometry. They interlink the core to core, tube to tube, and follow the basic functions that are required for the building. This is very important. So I always instruct my students, so before to design a building, just check out the requirement and make a sketch, and then you have to decide very properly, very honestly, the structural system. In this way, tube in tube structure, you can play as an interior designer, as an architect, a maximum open space for your liberty of your design. So we are going to discuss a new system, that is the mechanics of viscosity materials devices that were used in the building. So these are used at the structural joints to absorb the energy generated by the wind or earthquake forces and eliminate vibrator or the oscillatory motions and prevent the destruction resonances from occurring. So we know every tall building, every longer span building of in concrete after 100 meters, we use a structural expansion joint. So first of all, we understand the expansion joint. Every building, every material in the world, in the construction industry, we consider the live material, live construction material. In the high temperature, they expand their position. In the cold temperature, they shrinkage and they reduce their status. So when the forces is applied on it, when the stress is applied on it, the material will absorb the pressure, the stress in the pressure of stress created by the wind or the earthquake. They absorb it and make it safe for any destruction. So we know in the polymer brand, polyurethane, rubber, and other lot of materials are used for the expansion joints or for the damping mechanics. So this is the another easiest, shortest way to we use it. These materials are new technologies with the expansion joints, with the structural joints, and we save the major destruction of the part. And that energy is saved in the building, and we use in the space of the in the joints of the buildings. Thank you for joining us. So now we discuss very shortly the assignments which I have posted in your Google Classroom. The assignments is related to this topic, and we have an interaction section, interactive session on tomorrow. So basically, the first assignment is to write a note on the different structural methods to design a high-rise building. So we discuss in this lecture, and you have to make an assignment. And the assignment is that discuss the effects of lateral movement in tube and tube structure. So these two assignments I have posted in your Google Classroom, and we have inshallah a class interactive session on tomorrow. If you have any query, any question, so we will discuss in that class session. So just as a review of this lecture, So we are going to discuss, not to going to discuss or design the structural mechanics, but we discuss as an architect what will be the methodology and what will be the procedure and what will be the format we must understand before to design a high rise. And today we are very clear. The tall buildings around our vicinity with only just with a column and frame structure, we are not going to consider a high rise. We say it's a low or medium high rise. They're just fixed with rigid frame structure and they are for high rise buildings. We need to save the building from the structural movement. We need a lateral stability in the structure. The 2 point is very important. We need to save the structure from the lateral movement and we require the structural stability. You know, in the government policy nowadays, so no structure will be approved by a clear defined structural stability certificate. Every government authority will make it compulsory. So they need a structural stability certificate. So when you are going to design a next semester's the high-rise building in your thesis work, you must consider the tube system, tube diagonal brace system, tube system with the rigid frame structures attached with the rigid frame structures, and in tube with the shear wall system. So these are basically the different flavors for an architect to choose it for the high rise. It is very important. We must have a clear understanding and we know the basic aspects of the structure. Before to conclude this lecture, the one thing is very important for an architect. We must have a clear knowledge where we are going to design the building. If we are going to design a building in Lahore, we must understand their earthquake positions and the zoning of the earthquake, the soil capacity, the availability of the materials, the availability of the skilled labor, and the sources. With respect to the project management, students, it is clear to understand that these type of projects require the resources. Number one resource is the human resources. Number two, the financial resources. Number three, the available resources of the materials. So we nowadays really lack in all areas. Have not a clear defined specialty in the high-rise buildings. We are lack of resources in our material and expertise. So we will inshallah work more and make a real and true high-rise buildings in our towns as per the following the current age requirements and the government policies. We are totally with our nation and to fulfill the requirements. Architects always build the nation to build the buildings. So the revision of this lecture is we definitely this lecture is related to the last lecture of the lateral stability. So thank you for joining in and for the question answer session we will have tomorrow. Thank you very much. Allah Hafiz.